thanks for giving me opportunity to for 10 minutes opportunity to talk about our recent results. And thanks to BG and Brendan for making my life easy. I'm not going to give any introduction here. I'll just focus on our results. So this is about investigation of collisional disalignment and polarization efficiency in one PDR IC63 and IC59 in H2 region Sh2-185. And thanks to my collaborators for helping me in this project. And as Brendan said, polarization, so understanding dust grain alignment, exploring dust grain alignment is important to see these beautiful maps of magnetic fields. So I'm not going through this slide because BG has given a very nice introduction that how rats are responsible for, or how rats can explain the grain alignment, interstellar grain alignment, and give us opportunity to map the magnetic fields in shorter and longer wavelengths. So in this talk, I'm going to focus on the results with two motivations. One is that how grain alignment can be affected, or how grains can be disaligned due to gas and dust collisions, and how grain alignment is affected by the strength of the radiation field. So we started the investigation of this H2 region, Sh2-185, where we had lots of polarization measurements, R-band polarization measurements, also V-band polarization measurements from BG's 2013 work and my 2017 work. This is a very close H2 region, so I think closest H2 region is 200 parsec. And the distances of these two nebulae, IC59, IC63, illuminated by B-type star gamma gas, are at a distance of 1.5 projected distance from the star. So first investigation, disalignment of the grains due to gas dust collisions. As I said, we have lots of polarization measurements in IC63 nebula. This is illuminated by gamma gas. And we have HCO plus J120 measurements from gamma. So we take an opportunity to use those line of sights where we have polarization measurements and we have gas HCO plus measurements, and we divided our sample into two populations. One is called a warmer population, another is a hotter population. And warmer are those line of sights which are not directly facing the radiation from gamma gas, and the hotter line of sights are that population is facing the radiation from gamma gas directly. So we wanted to see what happens to the polarization efficiency or polarization with the intensity of the HCO plus emission in this nebula. But before going to this right-hand side plot, I just want to introduce this left-hand side plot where Thi et al. In 2009 studied IC63 nebula, the same nebula, using pure rotation molecular hydrogen observations from SWS ISO. And using the rotation diagram information, he reported or he gave a hypothesis of presence of two temperature components in this nebula, hotter component and a warmer component. So we thought that if there are two temperature components in this nebula, maybe the two populations, we have the hotter population and the warmer population, may have different slopes or different distribution of the drop in polarization with the intensity of HCO plus gas. And we do see a steeper drop in the polarization. Delta P here is the difference between the measured polarization and the mean polarization in this nebula. And we do see a steeper drop in the polarization in the population, which is at the higher, relatively higher temperature compared to the warmer population. So this population is the population which is directly facing the radiation from gamma gas. So polarization drops steeply compared to the polarization drop in the blue population, which is at the warmer temperature. And we do see that first, there is a drop in the polarization with the increase in the HCO plus line of sight intensities. And also the rate of the drop in polarization depends on the temperature. So it depends on the higher the temperature, more are the collisions, so more is the rate of drop of polarization. So this was just one test on how collisional disalignment can affect the polarization and how it depends on the different temperature of the regions. So the second investigation on the same region was that as BJ said, that rat is able to describe this, or is able to prove the grain alignment and industrial polarization. So we wanted to do this test on rat, that if what happens if we keep on increasing the strength of the radiation, do we reach a limit where we where we get that all the grains are aligned, or where we have a saturation in the grain alignment efficiency and hence polarization efficiency, or what happens? So if we keep on population of those regions where radiation strength are different, what happens to the polarization efficiencies? So for example, these two regions where we have different strength of polarization, for example, Orion Nebula, which is very bright and illuminated by many O and B type stars. So PG already introduced their Elias and his work into 2019. What they did on local bubble, where they do find that grain alignment efficiencies are affected, are better correlated with the radiation from the O and P stars. And they also find that in the populations, that the chi-square, the reduced chi-square fit in the polarization efficiencies at the locations of the local bubble wall is better, or it's around, it's good at the locations where the radiation is coming from O and P stars. But as they keep on adding the radiation from the late type stars, there is a kind of noise adding to this reduced chi-square, and the grain alignment efficiency is not much affected by this, the light from the late type stars. So they did this investigation on local bubble, on different locations of the local bubble. So what we wanted to extend this investigation on IC63, where we have a well-defined illuminating source at a 1.5 parsec distance from the nebulae. We have extinction measurements and polarization measurements in these nebulae. Thus, we have a polarization efficiency measurement, and the system is very simple. We have a star with luminosity L star and radiating a cloud at a distance of R. So thus we can find the illuminating flux, and we have polarization efficiency measurements. So we wanted to compare these polarization efficiency measurements with the local bubble results.
3 more minutes.
Okay, thanks. So in this, we plotted a polarization efficiency. So beta sin psi inverse here shows a polarization, depicts polarization efficiency, and please go check Medan and Anderson 2019 for the explanation, and our paper also. So IC59, IC63 shows higher polarization efficiencies compared to local bubble results. And when we take the results of LDN204, which is illuminated by more O and B type stars, and the polarization measurements were taken from Cashman and Clemens's paper. So we do see that IC59, IC66 show very high or higher polarization efficiencies with the radiation flux compared to local bubble. The reason for that may be because IC59, IC63 are much closer to the radiation source as compared to the local bubble, where the distances of the radiation source was around 50 parsec or so. So these are just 1.3, 1.5 parsec. So maybe that's why the more radiation is coming, so more grain alignment is happening, so more polarization efficiency. And this is same explanation for LDN204. But we are now extending this study to further level by including more and more sample, such as Orion Whale, and we are going to include 4 more clouds from 1H2 region IC1396 soon. And when we plot the same figure in log scale, we do see a kind of saturation or kind of flattening of the polarization efficiencies in L204. And when we add Orion Whale, which is illuminated by several O and B type stars, and it has higher UV flux, we do see a kind of saturation in the polarization efficiency. But have we reached a saturation? No, maybe there are 2 cautionary remarks I want to put here, is that the destruction of the grains due to a rat has not been taken into account. So please go check Huang's 2019 paper, where they say about that the more rat can destruct the grains, and maybe the drop in polarization efficiency or saturation, the polarization efficiency can happen. And also we do need a multiband polarization information in these regions to constrain the grain sizes. Whatever we are showing here is based on our single band polarization measurements. So these are cautionary remarks, but we do see some kind of saturation in the polarization efficiency with the radiation strength. And yeah, I will leave you on my summary, and I do encourage you all to check our recent papers. One is on the enhancement in grain alignment due to H2 formation, or disalignment due to dust and gas collision, and other is about the change of the polarization efficiency with the radiation field strength and comparison to local bubble results. And we're going to extend this work in future. So I'll take questions if there are any.